Preparing for a database administrator interview. You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What are the core responsibilities of a database administrator in a production environment? A database administrator keeps data platforms reliable, secure, and recoverable. In practice, I manage schema changes, backups, performance tuning, access control, monitoring, and incident response. I also work with developers to review queries and indexes before they hit production. A strong DBA is not just reactive. I define standards, automate routine work, test recovery, and make sure the business can trust its data under load or failure. While answering, focus on availability, security, backups, recovery, performance tuning, access management, monitoring, patching, capacity planning, and collaboration with developers, DevOps, security, and business stakeholders. Question 2. How do you approach database performance tuning when users report slow application response times? I start by proving where the latency is coming from. I check database wait events, active sessions, slow query logs, CPU, memory, disk I/O, and connection counts. Then I inspect execution plans for expensive scans, bad joins, missing indexes, or outdated statistics. I avoid random tuning because it creates risk. After applying a fix, I compare before and after metrics and keep monitoring to ensure the improvement holds under real workload. Make sure to cover measuring before changing, identifying slow queries, checking execution plans, indexes, waits, locks, CPU, memory, I/O, statistics, and validating improvements with benchmarks. Question 3. What is an index, and how do you decide which columns should be indexed? An index is a data structure that helps the database find rows without scanning the whole table. I usually index columns used in where clauses, joins, sorting, and grouping, especially when they have good selectivity. For multi-column filters, I consider composite indexes in the same order queries use them. The trade-off is that indexes slow inserts, updates, and deletes, so I validate each index against real query patterns. In your answer, talk about index structures, lookup speed, selectivity, cardinality, query predicates, joins, ordering, write overhead, composite indexes, covering indexes, and avoiding over-indexing. Question 4. Explain the difference between clustered and non-clustered indexes. A clustered index defines the physical or logical order of table data, depending on the database engine. Because the data is stored with the clustered key, range queries on that key are efficient. A non-clustered index is a separate structure that points back to the base row. I choose clustered keys that are stable, narrow, and commonly used for access. Poor clustered keys can increase fragmentation and make every non-clustered index heavier. Be sure to mention physical row ordering, lookup behavior, primary key relationships, leaf-level storage, bookmark lookups, range queries, and why most tables should have a carefully chosen clustered key. Question 5. How would you design a backup and recovery strategy for a critical database? I design backups around business recovery goals, not just schedules. First, I define RPO and RTO, how much data we can lose, and how quickly we must recover. For a critical system, I use full backups, incremental or differential backups, and transaction log backups if supported. I encrypt backups, store copies off-site, and monitor failures. Most importantly, I regularly perform restore drills, because an untested backup is only a hope. While answering, cover RPO, RTO, full, differential, incremental, and log backups, backup encryption, off-site copies, retention policy, restore testing, automation, and documentation. Question 6. What is the difference between full, differential, incremental, and transaction log backups? A full backup captures the entire database at a point in time. A differential backup captures changes since the last full backup. An incremental backup captures changes since the last backup of any type, so it saves space, but can require more restore steps. Transaction log backups capture committed changes and enable point-in-time recovery. In production, I combine these to balance storage cost, backup window, and recovery speed. Make sure to distinguish what each backup captures: restore sequence, storage impact, recovery speed, log chain dependency, point-in-time recovery, and when each type is appropriate. Question 7. What are ACID properties, and why do they matter for database reliability? ACI describes the guarantees that make transactions trustworthy. Atomicity means a transaction fully succeeds or rolls back. Consistency keeps data valid according to constraints. Isolation prevents concurrent transactions from corrupting each other. Durability ensures committed data survives crashes. For example, in a bank transfer, debit and credit must happen together. As a DBA, I care about ACID because reliability problems often appear exactly at transaction boundaries. In your answer, explain atomicity, consistency, isolation, durability, transaction safety, failure handling, concurrent users, financial examples, and the trade-off between strict consistency and performance. Question 8. How do transaction isolation levels affect locking, consistency, and performance? Isolation levels control how much one transaction can see from another. Lower levels reduce blocking but may allow dirty reads, non-repeatable reads, or phantom reads. Higher levels like serializable give stronger correctness but can reduce concurrency. Many modern databases use MVCC to let readers and writers work with fewer conflicts. I choose isolation based on business impact. Reporting can tolerate relaxed reads, but payments or inventory usually need stronger guarantees. Be sure to cover read uncommitted, read committed, repeatable read, serializable, phantom reads, dirty reads, non-repeatable reads, MVCC, blocking, and choosing isolation based on risk. Question 9. What is a deadlock, and how would you investigate and prevent it? A deadlock happens when two or more transactions wait on each other's locks, and none can proceed. I investigate by reviewing deadlock logs or graphs to identify the statements, objects, lock modes, and transaction order. Prevention usually means accessing tables in a consistent order, keeping transactions short, adding indexes to reduce locked rows, and avoiding user interaction inside transactions. The application should also retry deadlock victims safely. While answering, focus on circular lock dependency, deadlock graphs, victim selection, transaction order, short transactions, proper indexes, retry logic, lock escalation, and application coordination. Question 10. How do you monitor database health in production? I monitor the database at several layers: availability, resource usage, workload, and data protection. Key metrics include CPU, memory, disk latency, storage growth, active sessions, slow queries, locks, replication lag, cache hit ratio, and backup success. I also establish baselines, because a metric is only meaningful in context. Good monitoring alerts early, avoids noise, and points to probable causes, not just symptoms. Make sure to mention proactive monitoring, baseline metrics, query latency, CPU, memory, disk I/O, storage growth, replication lag, locks, connection pools, backup status, alerts, and dashboards. Question 11. What steps would you take if a database suddenly runs out of disk space? First, I protect availability by checking whether storage can be expanded quickly or non-critical files can be moved safely. Then I identify what grew: data files, transaction logs, temp space, indexes, audit tables, or failed backup artifacts. I avoid deleting unknown files because that can cause corruption. After stabilizing, I fix the root cause with log backups, retention cleanup, archiving, partitioning, or capacity alerts. In your answer, talk about immediate containment, identifying growth sources, logs, temp files, indexes, backups, archiving, emergency expansion, cleanup safety, and long-term capacity controls. Question 12. Explain database replication and the difference between synchronous and asynchronous replication. Replication copies data from a primary database to one or more replicas. Synchronous replication waits for the replica to confirm the write before committing, which reduces data loss risk, but adds latency. Asynchronous replication commits on the primary first, so it is faster, but can lose recent changes during failover. I use replication for high availability, disaster recovery, and read scaling, but I always monitor lag and test failover. Be sure to include primary replica architecture, read scaling, high availability, failover, replication lag, commit acknowledgement, data loss risk, latency trade-offs, and monitoring requirements. Question 13. How would you plan a database migration with minimal downtime? I treat migration as a controlled release. I start with inventory, compatibility checks, schema conversion, and performance testing on realistic data. For minimal downtime, I prefer replication-based migration. Load historical data, keep changes in sync, validate row counts and checksums, then perform a short cutover. I prepare rollback steps before touching production. After cutover, I monitor errors, query latency, replication remnants, and business-critical workflows closely. While answering, cover assessment, schema compatibility, data validation, replication or dual writes, cutover planning, rollback strategy, testing, stakeholder communication, freeze windows, and post-migration monitoring. Question 14. What is database normalization, and when would you denormalize a schema? Normalization organizes data to reduce duplication and prevent update, insert, and delete anomalies. For example, customer details should not be copied into every order row if they can be referenced by customer ID. I denormalize when read performance or reporting simplicity justifies controlled duplication. The key word is controlled. I document ownership, refresh logic, and consistency rules. Denormalization is a performance tool, not an excuse for messy design. Make sure to explain reducing redundancy, data integrity, normal forms, anomalies, joins, reporting workloads, read performance, controlled duplication, and documenting denormalized data maintenance. Question 15. How do you secure a database against unauthorized access and data leakage? I secure databases using defense in depth. Access starts with least privilege, role-based permissions, strong authentication, and separate admin accounts. Data should be encrypted at rest and in transit, with keys managed properly. I restrict network access, rotate credentials, audit sensitive activity, and patch regularly. For non-production, I mask or anonymize production data. Security is not one setting, it is continuous review, monitoring, and disciplined change control. In your answer, cover least privilege, role-based access, strong authentication, encryption at rest and in transit, auditing, patching, network controls, secrets management, masking, and compliance. Question 16. What is partitioning and how can it improve manageability and performance? Partitioning splits a large table into smaller logical pieces, usually by range, list, or hash. A common example is partitioning orders by month. Queries that filter by order date can scan only relevant partitions, and maintenance tasks like archiving old data become easier. Partitioning is not magic though. If queries do not include the partition key, or the key creates skew, performance may not improve. Be sure to mention horizontal data division, range, list, hash partitioning, partition pruning, maintenance windows, archival, large tables, query patterns, and risks of poor partition keys. Question 17. How do you handle schema changes in a high-traffic production database? For high-traffic systems, I make schema changes backward compatible. I avoid one big breaking change. A safe pattern is expand, migrate, contract. Add new columns or tables, deploy code that writes both paths, backfill gradually, switch reads, then remove old structures later. I check whether DDL operations lock tables and use online options when available. Every migration needs testing, monitoring, and a rollback or mitigation plan. While answering, discuss backward compatible migrations, online DDL, locking impact, phased deployments, feature flags, migration scripts, testing, rollback, index creation strategy, and communication with application teams. Question 18. How would you troubleshoot high CPU usage on a database server? I first confirm whether CPU is truly the bottleneck or just a symptom of I/O waits or blocking. Then I identify top CPU-consuming queries using monitoring views, query store, or slow query logs. I review execution plans for scans, bad joins, missing indexes, stale statistics, and excessive parallelism. I also check batch jobs and connection spikes. The fix may be query tuning, indexing, scheduling changes, or capacity scaling. Make sure to cover workload spikes, top queries, execution plans, missing indexes, recompilation, parallelism, statistics, connection storms, background jobs, waits, and separating CPU from I/O issues. Question 19. What is the role of statistics in query optimization? Statistics describe data distribution, such as row counts and value frequency. The optimizer uses them to estimate how many rows a query will return and choose join types, index usage, and access paths. If statistics are stale, the optimizer may pick a terrible plan even when indexes exist. I keep statistics updated, especially after large data changes, and I investigate estimate versus actual row differences during performance tuning. In your answer, explain cardinality estimates, data distribution, optimizer decisions, execution plans, stale statistics, auto-update behavior, large tables, parameter sensitivity, and maintenance schedules. Question 20. How do managed cloud databases change the role of a DBA? Managed databases remove much of the server maintenance, but they do not remove DBA responsibility. The cloud provider handles parts of patching, storage, backups, and high availability, depending on the service. I still own schema design, indexes, query tuning, access control, parameter configuration, monitoring, cost control, and recovery testing. The role shifts from racking servers to engineering reliable data services within the provider's constraints and pricing model. Be sure to mention reduced infrastructure management, shared responsibility, backups, patching, monitoring, parameter tuning, cost optimization, scaling, security configuration, HA options, and vendor limitations. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.